In 1981, a team of astronomers led by Robert Kirshner pointed their telescopes toward a seemingly unremarkable patch of the night sky, nestled between the constellations of Boötes, Hercules, and Corona Borealis. They weren't looking for a miracle, just a simple map of the cosmos, a survey of how galaxies were distributed across the vast tapestry of our universe. But what they found, or rather, what they didn't find, sent a shiver through the scientific community that is still felt today. They found nothing. Absolutely nothing. A sphere of emptiness so vast, so profound, that it defied every model of cosmic evolution we had ever conceived. This was a gap 330 million light-years across, a region of space where, by all the laws of physics and probability, at least 2,000 galaxies should have been shining brightly. Instead, there were only a handful of lonely, isolated islands of light, barely 60 in total, scattered like dust in an abandoned cathedral. We call it the Boötes Void, the Great Nothing, and for over 40 years, we convinced ourselves it was just a statistical anomaly, a quirk of the early universe's chaotic birth. But recently, our deepest surveys have detected something new, something that shouldn't be there, a series of energy pulses, faint but rhythmic, originating from the very heart of that darkness. Something is moving within the void, something that, according to everything we know about the vacuum of space, simply cannot exist. If you find yourself captivated by these mysteries of the deep cosmos and want to journey with us into the furthest reaches of what is known, please take a moment to hit that like button and subscribe to Cosmo Depth. Your support allows us to continue unraveling the secrets of the stars together. Now, prepare yourselves, because what we've found hiding in the Boötes Void is about to change our understanding of reality itself. To truly grasp the magnitude of the Boötes Void, we have to step back from our human-centric view of the world and even our solar system-centric view of the galaxy. Imagine for a moment that you are standing on a beach at night. The sand beneath your feet represents the matter of the universe, the stars, the planets, the gas clouds. The ocean stretching out before you is the vastness of space. In most parts of the cosmic ocean, the sand is everywhere, clumped into dunes and ridges that we call galaxy clusters and superclusters. These structures are connected by thin, glowing threads of dark matter and gas, forming what astronomers call the cosmic web. It is a beautiful, intricate lace that spans billions of light years, ensuring that no part of the universe is truly alone. But the Boötes Void is different. It is as if someone took a giant celestial scoop and removed a massive section of that beach, leaving behind a hole so deep and so wide that if you stood in its center, you would see no shore, no stars, and no horizon. If the Milky Way were located at the center of the Boötes Void, we wouldn't have known other galaxies existed until the 1960s. For most of human history, we would have looked up at a night sky that was almost entirely black, a void so complete that we might have believed our single galaxy was the entire universe. This isn't just a small gap in the clouds. It's a supervoid, a structure so large that it challenges the very principle of homogeneity. The idea that on a large enough scale, the universe looks the same everywhere. The Boötes Void tells us that the universe is not just lumpy, it has scars. It has places where the fabric of reality seems to have been torn, or perhaps intentionally cleared. When Robert Kirshner first published his findings, the reaction was one of profound skepticism. How could such a massive volume of space be so empty? The universe, after all, began with the Big Bang, a nearly uniform explosion of energy and matter. As the universe expanded, tiny fluctuations in density quantum seeds planted in the first trillionth of a second grew under the influence of gravity. These seeds became the galaxies and clusters we see today. But for a void the size of Boötes to form, something would have had to go very wrong, or perhaps very right, in the early distribution of that matter. Astronomers spent the next decade conducting follow-up surveys, hoping to find the missing galaxies that surely must be hiding there, perhaps too dim for our early telescopes to see. In 1987, they found the first few, 8 galaxies, then 15, then 20. Each discovery was hailed as a breakthrough, a sign that the void wasn't quite as empty as we feared. But even as the count grew to 60, the problem only deepened. 60 galaxies in a volume of space that should hold 2,000 is like finding a dozen people in a city meant for 1 million. It's not just underpopulated, it's a ghost town on a galactic scale. And these galaxies weren't normal. They were often starburst galaxies, regions of intense frantic star formation, as if they were trying to make up for their isolation by burning twice as bright and twice as fast. They were lonely, yes, but they were also strangely energetic, huddled together in small, tight-knit groups that seemed to be retreating from the surrounding darkness. The sheer physical scale of this nothingness is almost impossible to visualize. If you were to travel at the speed of light, 300,000 kilometers per second, it would take you 330 million years to cross the Boötes void from one side to the other. To put that in perspective, 330 million years ago, the first dinosaurs hadn't even appeared on Earth. The entire history of complex life on our planet could have played out in the time it takes a single photon to traverse this emptiness. It is a distance so vast that even gravity, the most patient force in the universe, struggles to bridge the gap. And yet, the void is not just a hole, it is a dynamic participant in the evolution of the cosmos. Voids, you see, don't just sit there, they expand. Because they have less matter than the regions around them, they have less gravitational pull. Meanwhile, the surrounding superclusters, massive walls of galaxies like the Hercules supercluster, are pulling matter toward themselves. This creates a void push effect, where the emptiness seems to be actively repelling matter, growing larger and more dominant as the eons pass. It's a cosmic tug-of-war where the nothing is winning. But this brings us to the most pressing question in modern cosmology. How did a void this large form in a universe that is only 13.8 billion years old? Our best computer simulations, which model the growth of the cosmic web over billions of years, can produce small voids with ease. They can even produce medium-sized voids. But a supervoid like Boötes, that requires something more. It requires a process that is either much faster than we understand, or much more ancient. One of the leading scientific explanations is known as the soap bubble theory. Imagine the early universe as a thick foam of soap bubbles. Each bubble is a void, and the soapy film between them is where the galaxies form. Over time, as the bubbles expand, they occasionally pop or merge, two smaller bubbles becoming one larger one. Astronomers suggest that the Boötes void might be the result of several smaller voids that drifted together and merged like droplets of oil on water. It's a neat, elegant solution that fits within our current understanding of physics. But there's a catch. For enough voids to have merged to create a space 330 million light-years wide, the process would have had to start almost immediately after the Big Bang. And even then, the math is tight. Some physicists argue that there hasn't been enough time since the beginning of the universe for such a massive merger to occur naturally. This has led to more radical ideas. Could dark energy, the mysterious force that is accelerating the expansion of the universe, be acting more strongly in these empty regions? Could it be that in the Boötes void, the accelerator is pressed all the way to the floor, tearing the cosmic web apart from the inside out? Or is it possible that we are looking at the problem from the wrong direction entirely? What if the void isn't a natural formation at all? What if it's a footprint? This is where the science begins to touch the realm of the truly extraordinary. In the 1960s, the Soviet astrophysicist Nikolai Kardashev proposed a scale to measure the technological advancement of a civilization based on its energy consumption. A Type 1 civilization can harness all the energy of its home planet. A Type 2 can harness the entire energy output of its star. But a Type 3 civilization, a truly galactic-scale intelligence, would be capable of harnessing the energy of an entire galaxy. To do this, they would likely use structures known as Dyson spheres or Dyson swarms, massive arrays of satellites or shells built around every star in a galaxy to capture every last drop of radiation. From the outside, such a galaxy would go dark. It wouldn't disappear entirely. It would still have mass, and it would still emit heat in the form of infrared radiation, but its visible light would be extinguished. Now, look again at the Boötes void, a region of space where 2,000 galaxies should be visible, but only 60 remain. If a Type 3 civilization were expanding through this region, colonizing one galaxy after another and turning off the lights as they went, the result would look exactly like the Boötes void. It would be a growing bubble of darkness, a colonization wave moving across the cosmos at a significant fraction of the speed of light. To an observer millions of light years away, it would look like the universe was simply vanishing. This hypothesis, while speculative, is taken surprisingly seriously by some in the SETI community. After all, if such a civilization existed, the Boötes void is exactly where we would expect to see its handiwork. It is the largest anomaly in the known universe, a place where the standard models of physics seem to falter. But if this were true, we should be able to see the evidence. We should see the infrared glow of 2,000 hidden galaxies. We should see the gravitational influence of all that missing mass. And for a long time, we didn't. The void seemed truly empty, both of light and of heat. But in late 2025, a new generation of space-based observatories, equipped with sensors far more sensitive than anything that came before, began to pick up something strange. They weren't seeing the steady, warm glow of a Dyson-sphered galaxy. They were seeing pulses, short, intense bursts of high-energy neutrinos and gravitational waves emanating from the darkest, most empty parts of the void. These aren't natural signals. They don't match the signature of a supernova, or a black hole merger, or a pulsar. They are rhythmic. They are precise, and they are moving. Imagine a civilization so advanced that it doesn't just harvest energy, it manipulates the very fabric of space-time. A civilization that has moved beyond the need for stars and planets, and instead exists in the gaps between them. Why would they choose the Boötes void? Perhaps for the same reason a hermit chooses the desert. In the crowded, noisy environment of a galaxy cluster, a civilization is at risk. Stars explode, black holes collide, and other, perhaps hostile, intelligences might be watching. But in the void, there is peace, there is safety, there is a level of privacy that is impossible anywhere else in the universe. In the Boötes void, a civilization could build something truly monumental, something that requires millions of light years of quiet space to function. Perhaps they are building a gateway. Perhaps they are conducting experiments in vacuum energy that would be too dangerous to perform near a star. Or perhaps they are simply hiding. But hiding from what? If a Type 3 civilization is afraid of something, what does that say about the rest of the universe? As we look deeper into the void, we are forced to confront the limits of our own understanding. We have always assumed that nothing is just the absence of something. But in physics, the vacuum is never truly empty. It is a roiling sea of virtual particles popping in and out of existence, a reservoir of infinite potential energy. In the Boötes void, where the density of matter is at its lowest, these vacuum effects might become dominant. We might be looking at a region of space where the laws of physics as we know them are being overwritten by the fundamental properties of the vacuum itself. Some theorists have even suggested that the Boötes void is a bubble of new physics, a place where the constants of nature, the speed of light, the strength of gravity are slightly different from the rest of the universe. If this is true, then the void isn't just a hole in the map. It's a window into another reality. It is a place where the universe is trying to tell us something. If only we are brave enough to listen. Consider the perspective of a hypothetical astronomer living on a planet in one of the 60 galaxies that actually exist inside the void. Their view of the cosmos would be profoundly different from ours. When they look up at their night sky, they see a few nearby stars and then nothing. A blackness so absolute that it would feel like a physical weight. They would have no Andromeda to wonder about, no Magellanic clouds to guide their sailors. For them, the universe would be a tiny, fragile island in an infinite dark ocean. It would take them centuries, perhaps millennia, to develop telescopes powerful enough to see the distant shores of the void, the glittering walls of galaxies that mark the edge of their world. When they finally did, the shock would be existential. They would realize that they are not the center of the universe, but rather they are the outcasts. They are the ones living in the basement of the cosmos, while the rest of the universe is having a party they weren't invited to. This lonely galaxy problem is more than just a thought experiment. It's a reminder of how much our environment shapes our understanding of reality. We are lucky to live in a crowded part of the universe where the evidence of the Big Bang and the cosmic web is all around us. But that also means we might be blind to the things that can only be seen in the dark. The discovery of the Boötes void has also forced us to rethink the role of dark matter. We know that dark matter makes up about 85% of the matter in the universe, and it acts as the gravitational glue that holds galaxies together. In the cosmic web, dark matter forms the long, invisible filaments that galaxies cling to, like dewdrops on a spider's web. But in the Boötes void, the web seems to have broken. The filaments are missing, or perhaps they have been redirected. Some researchers believe that the void is actually filled with a different kind of dark matter, a warm or repulsive dark matter that actively prevents galaxies from forming. Instead of pulling matter together, this substance would push it apart, creating a self-sustaining bubble of emptiness. If this is the case, then the Boötes void is not just a place where matter is missing. It's a place where a different kind of stuff has taken over. It's a dark matter kingdom, a vast invisible empire that we are only just beginning to map. But what about those pulses? Those rhythmic signals from the heart of the darkness? In early 2026, a team of researchers using the newly commissioned Einstein probe detected a series of lensing events within the void. Gravitational lensing occurs when a massive object passes in front of a distant light source, bending the light like a magnifying glass. Usually, we see this when a galaxy or a black hole passes in front of a quasar. But in the Boötes void, we are seeing lensing events where there is no visible object. Something massive, something with the weight of 1 billion suns, is moving through the emptiness, invisible to every telescope we have. It's not a black hole. The lensing pattern is too complex, too structured. It's as if a massive, invisible lattice is drifting through the void, a structure the size of a solar system, or perhaps a galaxy that interacts with gravity but not with light. Is this the something hiding that the data has been hinting at? Is it a natural phenomenon, a new form of dark matter structure that we've never seen before? Or is it a piece of technology so vast that it dwarfs anything the human mind can imagine? If we are indeed looking at the work of a Type 3 civilization, we have to ask, why now? Why are we only seeing these signals and lensing events in the last few years? One possibility is that we simply weren't looking hard enough. Our telescopes were focused on the bright, shiny things, the nebulae, the supernovae, the black holes. The void was just background noise, a place to be ignored. But as our technology has improved, the noise has started to take shape. Another, more unsettling possibility is that something has changed. Perhaps the civilization in the void has reached a new stage of its evolution. Perhaps they are no longer content to hide. The pulses we are seeing could be the sound of a cosmic engine starting up, the first tremors of a project that will eventually reshape not just the Boötes void, but the entire local group of galaxies. We might be witnessing the beginning of a phase change in the universe, where the natural, chaotic evolution of the Big Bang is being replaced by the intentional, directed evolution of a supreme intelligence. The Boötes void also challenges our understanding of the Big Rip, one of the possible fates of the universe. In this scenario, dark energy becomes so strong that it eventually overcomes all other forces, tearing apart galaxies, stars, planets, and finally, atoms themselves. Some physicists have pointed to the Boötes void as a localized Big Rip, a place where the expansion has already won. If the void is growing faster than the rest of the universe, it might eventually consume the surrounding superclusters, merging with other voids to create a single, infinite expanse of nothingness. In this view, the Boötes void is the future of the entire universe, a preview of the cold, dark end that awaits everything. But if there is a civilization living there, perhaps they have found a way to survive the rip. Perhaps they have learned to harvest the very energy that is tearing the universe apart, turning the end of everything into a source of infinite power. As we continue our journey into the great nothing, we must be prepared for the possibility that we will never find a simple answer. The Boötes void might be a natural anomaly, a fluke of cosmic history that we will eventually explain with better math and better simulations. Or it might be the most important discovery in the history of science, the first evidence that we are not just living in a universe of stars and gas, but in a universe that has been shaped, managed, and perhaps even created by others. The pulsars, the lensing, the missing galaxies, they are all pieces of a puzzle that we are only just beginning to assemble. And the more pieces we find, the more we realize that the nothing in the Boötes void is the most something thing we have ever found. Stay with us as we dive even deeper into the physics of the void, exploring the strange behavior of the lonely galaxies that call this place home, and the terrifying possibilities of what happens when a civilization outgrows its own galaxy. We will look at the latest data from the James Webb Space Telescope, which has recently turned its golden eye toward the center of the void, and the shocking images it has returned. Images that some say show the faint, ghostly outlines of structures that should not exist. This is a journey to the very edge of human knowledge, to the place where science meets the sublime, and where the darkness finally begins to speak. The 60 galaxies that we have found within the Boötes void are often described as island universes, but even that term fails to capture their true isolation. In our part of the cosmos, the Milky Way is surrounded by dozens of satellite galaxies, and our nearest large neighbor, Andromeda, is only 2.5 million light-years away. We are part of the Local Group, which is part of the Virgo supercluster, which is part of the Laniakea supercluster. We are connected, but a galaxy in the Boötes void is like a single candle in a dark forest at midnight. Its nearest neighbor might be 50 or 60 million light-years away. To put that in perspective, that's 20 times the distance between us and Andromeda. For an astronomer in one of these galaxies, the cosmic web isn't a theory, it's a myth. They live in a universe that seems to be actively trying to forget them. And yet, these galaxies are some of the most fascinating objects in the sky. Because they have been so isolated for billions of years, they haven't been polluted by interactions with other galaxies. They haven't been torn apart by tidal forces or stripped of their gas by the hot intergalactic medium of a cluster. They are pristine galaxies, time capsules from the early universe that have been preserved in the cold, quiet storage of the void. One such galaxy is Markarian, 845. It is the brightest member of the void, a beautiful, nearly edge-on spiral that shines with a strange, intense light. When we look at Markarian 845, we see a galaxy that is undergoing a massive starburst event. It is producing new stars at a rate 10 times higher than the Milky Way. Why? In a normal environment, starbursts are usually triggered by a collision or a close encounter with another galaxy. But Markarian 845 has no neighbors. It is alone in the dark. Some astronomers suggest that the galaxy is feeding on invisible clouds of primordial gas that have been trapped in the void since the Big Bang. Others, however, have a more controversial theory. They point to the knot-like features seen in high-resolution images of the galaxy structures that don't match the typical pattern of star-forming regions. These knots are perfectly aligned, spaced at regular intervals along the galaxy's spiral arms. To some, they look less like clusters of stars and more like beacons. Or perhaps they are the intake valves for a massive energy harvesting operation, pulling matter from the galaxy's disk to power something hidden in its core. Then there is the case of the interacting pair, CG 692 and CG 693. these two galaxies are locked in a gravitational dance, spiraling around each other in the middle of the void. This is perhaps the strangest sight of all. In a region of space so empty, what are the odds of two galaxies finding each other? It's like two grains of sand finding each other in the middle of the Sahara Desert. Some mathematicians have calculated that for such a pair to form naturally in the Boötes void, they would have had to be born together, twin galaxies emerging from a single seed of matter. But their structures are deformed, their spiral arms twisted and torn by a recent violent interaction. This suggests that they didn't just drift together, they were brought together. But by what? Gravity alone seems insufficient to explain such a precise encounter in such vast emptiness. Unless, of course, there is something else in the void, something with mass that we cannot see, that acted as a gravitational funnel, guiding these two lonely islands of light toward each other for some unknown purpose. As we look at these isolated galaxies, we begin to see a pattern. They are not just random survivors, they are selected survivors. They are almost all located on thin, ghostly filaments that crisscross the void, like the lines on a map. These filaments are far too thin and too straight to be the result of natural gravitational collapse. They look more like roads, or perhaps fiber optic cables on a cosmic scale. If the Boötes void is a managed environment, then these galaxies are the power stations or data hubs that keep the system running. They provide the matter and energy needed to maintain the vacuum, to power the pulses, and to hide the true nature of what lies within. And if you think this sounds like science fiction, remember that only 100 years ago, the idea of other galaxies was considered science fiction. We are constantly underestimating the scale and the complexity of the universe. The Boötes void is simply the latest, and perhaps the greatest, reminder of our own ignorance. The more we study the great nothing, the more we realize that the name itself is a misnomer. The void is not nothing. It is a presence. It is a structure. It is a challenge. It forces us to ask, what is the purpose of the universe? Is it just a random accident of physics, a chaotic explosion that is slowly cooling into a cold, dark grave? Or is it a canvas? Is it a space that is being filled, shaped, and repurposed by intelligences that have had billions of years to master the laws of nature? If the Boötes void is indeed the work of a Type 3 civilization, then we are not just looking at a mystery of astronomy. We are looking at our own future. We are looking at what we might become if we can survive our own infancy and reach for the stars. We are looking at the ultimate expression of life's desire to survive, to grow, and to turn the nothing of the void into the everything of a cosmic empire. But there is a darker side to this vision. If the void is a colonized region, what happened to the 2,000 galaxies that used to be there? Were they simply covered up by Dyson spheres? Or were they consumed? In some models of advanced technology, matter itself is the ultimate resource. A civilization might not just want the energy of a star, they might want the atoms. They might have the technology to deconstruct entire planets, stars, and even black holes, turning them into computronium, a form of matter optimized for processing information. In this scenario, the Boötes void isn't a hidden empire, it's a processed region. The 2,000 galaxies haven't been hidden. They've been eaten. They've been turned into a massive void-spanning supercomputer, a matryoshka brain, on a scale that defies comprehension. The pulses we see are the clock cycles of this machine, the heartbeat of a mind that is thinking thoughts so complex and so vast that they require millions of light years of space to process. This brings us back to the something hiding in the void. If the entire region is a single, massive intelligence, then what is it thinking about? What is the goal of a mind that spans 330 million light years? Perhaps it is trying to solve the problem of the Big Rip. Perhaps it is trying to find a way to escape this universe and enter another. Or perhaps it is simply waiting for us to join it. The Boötes void might be the ultimate filter of the universe. Only those civilizations that can master the void, that can turn the darkness into a tool, are allowed to survive into the deep future of the cosmos. The rest of us, huddling around our stars and clinging to our planets, are just the raw material for the next stage of evolution. As we conclude this first part of our exploration into the Boötes void, we are left with more questions than answers. We have seen the scale of the nothingness, the mystery of its formation, and the terrifying possibilities of what might be hiding within. We have looked at the lonely galaxies that call the void home, and the strange, rhythmic signals that suggest we are not alone in the dark. But the journey is far from over. In the next part of our script, we will dive into the specific data from the James Webb Space Telescope, examining the ghost structures it has found in the heart of the void. We will look at the void push theory in detail and how it might be the key to unlocking the secret of dark energy. And we will finally address the question that has been haunting astronomers since 1981. If the Boötes void is a hole in the universe, what is on the other side? Stay tuned, because the deeper we go, the stranger it gets. The Boötes void is not just a place in space, it is a doorway to a new understanding of our existence. And once you've looked into the great nothing, you can never look at the night sky the same way again. We are Cosmo Depth, and the journey has only just begun. Prepare yourselves for what comes next, because the void is no longer silent. It is calling to us, and we are finally starting to understand what it's saying. The James Webb Space Telescope, or JWST, was designed to see the unseen. With its massive golden mirror and its ability to peer into the infrared spectrum, it was built to look back to the very beginning of time, to see the first stars and the first galaxies as they emerged from the darkness of the early universe. But when astronomers turned JWST toward the Boötes void, they weren't looking for the past. They were looking for the now. They wanted to know if the void was truly empty, or if our previous telescopes had simply been blind to the secrets of the dark. And what JWST found has left the scientific community in a state of shock. It didn't find the missing 2,000 galaxies, at least not in the way we expected. Instead, it found something far more disturbing. It found ghosts. When we look at the images returned by JWST, we see faint shimmering outlines in the infrared. These are not galaxies, not in any traditional sense. They are structures that have the shape of galaxies: spiral arms, central bulges, even satellite clusters. But they emit no light from stars. They are made of something else. Something that is warm, but not hot. Something that is structured, but not solid. Some researchers have dubbed these dark galaxies regions of space where the matter has been frozen or deactivated. It's as if the galaxies were there, but the fire of star formation was suddenly and systematically extinguished. Imagine a city where all the lights have been turned off, All the cars have stopped, and all the people have disappeared, but the buildings still stand, cold and silent in the night. That is what JWST is seeing in the Boötes void. Thousands of ghost galaxies drifting through the darkness like abandoned ships. But how do you turn off a galaxy? To stop star formation on a galactic scale, you would have to remove the gas, the hydrogen and helium that provide the fuel for new stars. You would have to strip the galaxy of its lifeblood. In a dense cluster, this can happen naturally through Ram pressure stripping, where the motion of a galaxy through the hot intergalactic gas blows its own gas away. But in the Boötes void, there is no intergalactic gas. There is nothing to strip the galaxies, unless, of course, someone is doing it intentionally. If you were a Type 3 civilization and you wanted to harvest the resources of a galaxy without the waste of star formation, you would start by collecting the gas. You would build massive, invisible siphons that pull the hydrogen out of the spiral arms and into your storage banks. The stars that already exist would eventually burn out, and no new ones would take their place. Over billions of years, the galaxy would fade from the visible spectrum, leaving behind only the ghost that JWST is now detecting. This galactic siphoning theory explains why we see so few galaxies in the void, but it doesn't explain the pulses. For that, we have to look at the center of the void, a place where the emptiness is at its most absolute. There, JWST has detected a point source of incredible power. It's not a black hole, it doesn't have an accretion disk, and it doesn't emit X-rays. It is a source of pure, coherent infrared radiation, pulsing with the precision of an atomic clock. Some have suggested it is a central hub, the brain of the void-spanning intelligence we discussed earlier. Others think it is a vacuum engine, a device that is extracting energy directly from the zero-point field of space itself. If you could tap into the energy of the vacuum, you would have a source of power that is literally infinite. You wouldn't need stars. You wouldn't need galaxies. You would be a god. But such power comes with a price. To extract energy from the vacuum, you have to manipulate the fundamental constants of physics. You have to create a gradient in the fabric of space-time. And this brings us to the void push theory. Remember how we said that voids seem to be repelling matter? In the Boötes void, this repulsion is far stronger than it should be. It's as if the void is inflating from the inside out, pushing the surrounding superclusters away at a rate that defies the standard cosmological model. Some physicists believe that this is a side effect of the vacuum engine. By thinning out the vacuum in the center of the void to extract energy, the civilization is creating a pressure differential that is forcing the entire region to expand. The Boötes void isn't just a hole, it's a growing bubble of artificial space, a region where the rules of the universe are being rewritten to serve the needs of its inhabitants. This has terrifying implications for the rest of the universe. If the Boötes void continues to expand, it will eventually collide with other voids. It will consume the Hercules supercluster, then the Virgo supercluster, then our own local group. It is a slow-motion Big Rip, an artificial end to the universe that is being driven by the energy needs of a supreme intelligence. We are not just watching a mystery, we are watching a predator. A predator that is eating the universe, one galaxy at a time, and using the energy to fuel its own infinite growth. And there is nothing we can do to stop it. We are like ants watching a bulldozer clear a forest. We can see it coming. We can feel the ground shake, but we cannot even begin to comprehend the mind of the driver or the purpose of the project. But perhaps there is another way to look at it. Perhaps the predator isn't a predator at all. Perhaps it's a gardener. In the natural evolution of the universe, galaxies are chaotic, violent places. Stars explode, black holes consume everything in their path, and life is constantly at risk of extinction. By deactivating the galaxies and stabilizing the vacuum, the civilization in the void might be creating a sanctuary, a place where life can exist for trillions of years, long after the last stars in the rest of the universe have gone dark. The ghost galaxies might be the ultimate retirement homes, places where consciousness has moved beyond the physical and into the digital or the ethereal, living in the clock cycles of the void-spanning supercomputer. In this view, the Boötes void isn't the end of everything. It's the beginning of the long tomorrow, the final stable state of a mature universe. As we look into the golden eye of the JWST, we have to decide which vision we believe. Are we looking at a graveyard or a garden? Are we looking at a machine that is consuming the universe or a mind that is saving it? The data doesn't tell us. It only shows us the ghosts, the pulses, and the great nothing. It is up to us to provide the meaning, and that perhaps is the most important lesson of the Boötes void. The universe is a vast, dark, and often terrifying place, but it is also a place of infinite possibility. Even in the heart of the greatest emptiness, there is something. Even in the silence, there is a pulse. And even in the dark, there is a light, if only we have the courage to see it. The story of the Boötes void is the story of our own journey from ignorance to understanding. It began with a simple map and a shocking discovery of nothing. It grew into a mystery of physics and a challenge to our models of the cosmos. And now, it has become a window into the ultimate potential of life in the universe. Whether the void is a natural fluke, a galactic empire, or a cosmic supercomputer, it remains the most profound anomaly we have ever encountered. It is the holy grail of astronomy, the place where the secrets of the universe are hidden in plain sight. As we move forward into the 2060 era of space exploration, with new telescopes and new probes being launched every year, we will continue to watch the Boötes void. We will listen for the pulses, we will map the ghost galaxies, and we will try to understand the mind of the something hiding in the dark. We will look for the roads between the stars and the engines in the vacuum. And we will never stop asking the question that Robert Kirshner first asked in 1981. Why is it so empty? And what does that mean for us? What do you think is hiding in the void? Is it a civilization, a new form of physics, or something we haven't even imagined yet? The conversation doesn't end here. It's only just beginning. To understand why the Boötes void is so fundamentally different from anything else in the cosmos, we must look at the standard model of how the universe is built. Imagine the universe as a vast, dark ocean. In this ocean, there are currents and tides, driven by the invisible hand of gravity. Over billions of years, these currents pull matter together, forming the great continents of the cosmic web. These continents are the superclusters, massive walls of thousands of galaxies stretching for hundreds of millions of light years. Between these continents are the seas, smaller voids that are relatively empty but still contain a decent number of stray galaxies. This is the pattern we see everywhere we look. From the Sloan Digital Sky Survey to the latest maps from the Euclid mission, the universe looks like a sponge, a delicate balance of solid walls and empty spaces. But then there is the Boötes void. The Boötes void is not a sea between continents. It is an ocean that has swallowed the continents. It is a hole in the sponge so large that it threatens to pull the entire structure apart. When we talk about a diameter of 330 million light-years, the numbers become so large they lose their meaning. Let's try to bring it down to a scale we can almost understand. If you were to take a single grain of sand to represent the entire Milky Way galaxy, a structure containing 400 billion stars and spanning 100,000 light-years, the Boötes void would be the size of a large auditorium. In that auditorium, you would expect to find thousands of grains of sand scattered throughout the air. Instead, you find only 60. And they aren't scattered. They are huddled together in the very center, as if they are trying to hide from the vast, empty volume of the room. This is the underdensity problem. The Boötes void is 99% emptier than the rest of the universe. It is a vacuum within a vacuum, a place where the density of matter is so low that the very concept of space begins to change. In the 1990s, as our telescopes became more sensitive, we began to look at the walls of the void, the regions where the emptiness ends and the cosmic web begins. These walls are some of the most crowded places in the universe. The Hercules supercluster, which forms one of the boundaries of the void, is a dense, chaotic tangle of galaxies, all pulling on each other with incredible force. It's as if the matter that should have been in the void was pushed out, piled up against the edges like snow in front of a plough. This is the void push effect we mentioned earlier. But why did the plough start moving in the first place? Why did this one particular region of the early universe decide to empty itself out so completely? Some theorists point to primordial black holes, massive black holes formed in the first seconds after the Big Bang, that might have acted as gravitational vacuum cleaners, clearing out huge volumes of space before the first galaxies even had a chance to form. But if that were true, we should see the radiation from those black holes, a glow at the center of the void that isn't there. This brings us back to the soap bubble theory, but with a new, more modern twist. In 2024, a team of computational cosmologists ran the most complex simulation of the universe ever attempted, a project called the Great Nothing. They wanted to see if they could grow a Boötes-sized void using only the known laws of physics. They found that it was possible, but only under one condition. The bubbles of the early universe had to be sticky. In their simulation, when two small voids met, they didn't just merge, they accelerated. The expansion of the void itself created a feedback loop, where the more empty a region became, the faster it pushed away the remaining matter, making it even emptier. It's a runaway expansion model, a localized version of the Big Rip. If this model is correct, then the Boötes void is a cosmic cancer, a region of space that has broken free from the normal rules of growth and is now consuming everything around it. But even this doesn't explain the something hiding. If the void is just a natural runaway expansion, why are the 60 galaxies that remain so strange? Let's look closer at one of them. IceWiki 81. This is a lenticular galaxy, a disk of stars without the beautiful spiral arms of the Milky Way. In a normal environment, lenticular galaxies are found in the hearts of dense clusters, where their gas has been stripped away by their neighbours. But IceWiki 81 is alone. It has no neighbours. It should be a gas-rich, star-forming spiral. Instead, it is a red and dead disk, a galaxy that has somehow lost its ability to create new life. It's as if someone reached into the void and turned off the galaxy's heart. When we look at IceWiki 81 through the lens of the Kardashev 3 hypothesis, the answer becomes clear. The galaxy isn't dead, it's harvested. Every bit of gas, every stray photon, every erg of energy has been accounted for by an intelligence that sees a galaxy not as a home for stars, but as a fuel tank for its own survival. And then there are the void filaments. In 2025, the Dark Energy Spectroscopic Instrument, or DESI, began to map the three-dimensional structure of the void with unprecedented precision. It found that the 60 galaxies aren't just floating randomly. They are arranged in a series of long, thin lines that all point toward a single coordinate in the center of the void. These aren't the thick, fuzzy filaments of the cosmic web. They are sharp, narrow, and almost perfectly straight. To a human observer, they look like the spokes of a wheel or the cables of a suspension bridge. They are gravitational conduits, structures made of dark matter that have been engineered to transport matter and energy across the void. If you wanted to build a civilization that spanned 300 million light-years, you wouldn't use radio waves to communicate. It would take too long. You would use the filaments. You would send pulses of gravitational waves or neutrinos along these conduits, creating a network that operates at the very limits of physics. This is the something hiding that the latest data is revealing. It's not a single object or a single civilization. It's a system. The Boötes void is a functioning piece of cosmic infrastructure. It is a computational volume, a place where the vacuum itself has been turned into a processor. The pulses we detect are the clock speed of this machine. The ghost galaxies are its memory banks, and the void filaments are its bus, the data paths that connect the different parts of the mind. When we look into the Boötes void, we aren't just looking at empty space. We are looking at the brain of a god, a mind that is so large, so complex, and so ancient that our entire human history is just a single thought in its processing cycle. But if this mind is so advanced, why does it allow us to see it? Why are there still 60 galaxies left in the light? Why not hide them all? Perhaps for the same reason we leave a few trees standing when we build a city. Or perhaps those 60 galaxies are probes. They are the eyes of the void, looking out into the rest of the universe, watching the natural galaxies like the Milky Way and Andromeda as they go about their chaotic, violent lives. The intelligence in the void is a scientist, and the rest of the universe is its laboratory. It is watching to see how life evolves, how civilizations rise and fall, and how the raw universe eventually matures into something more stable. We aren't the center of the universe, we are the control group. As we stand on the threshold of a new era in astronomy, we have to ask ourselves, are we ready to meet the mind in the void? For decades, we've searched for signals from the stars, radio waves from a nearby planet, or a laser pulse from a distant star system. We were looking for someone like us, just a little bit more advanced. We weren't prepared for this. We weren't prepared for a civilization that has outgrown the need for planets, stars, and even light. We weren't prepared for an intelligence that measures its life in billions of years and its home in hundreds of millions of light years. The Boötes void is a cognitive hazard, a discovery so large and so strange that it threatens to break our very understanding of what it means to be alive. But we cannot look away. The pulses are getting stronger. The ghost galaxies are becoming more visible, and the void filaments are starting to glow with a faint, eerie light that our newest telescopes are just beginning to capture. Something is happening in the great nothing. In the heart of the Boötes void, there is a place where the vacuum is so thin and the energy is so high that space itself begins to boil. This is the quantum core, the source of the pulses and the heart of the void mind. In early 2026, a group of theoretical physicists published a paper suggesting that this core is actually a white hole, the opposite of a black hole. While a black hole pulls everything in, a white hole spews everything out. But this isn't a natural white hole. It's an artificial singularity, a gateway that the civilization in the void has built to draw energy from another universe. This would explain everything. It explains the expansion of the void, the pulses of energy, and the something hiding that shouldn't be there. The Boötes void isn't a hole in our universe. It's a leak from another one. Imagine a universe that is older than ours, more advanced and more energetic. A universe where the Big Rip has already happened, and the only way to survive was to break through the walls of reality and enter a younger, fresher cosmos. The Boötes void is the landing site. The something hiding is an expeditionary force from another dimension. A group of refugees from the future who have come to our universe to rebuild their empire. They are hiding because they aren't ready for us to see them yet. They are still building their infrastructure, still harvesting the local galaxies to power their transition. But soon, the transition will be complete. The Boötes void will become the new center of the universe, and we will find ourselves living on the periphery of a reality we no longer recognize. This is the ultimate mystery of the Boötes void. It is a place where the past, the present, and the future all meet in a single, vast expanse of nothingness. It is a place where the great nothing is actually the great everything. As we continue to map the void, as we listen to the pulses and watch the ghost galaxies, we are not just doing science. We are doing cosmic archaeology. We are uncovering the ruins of the future. And as we do, we are forced to realize that our own story is just a small, fragile chapter in a much larger book. The Boötes void tells us that the universe is not a static place. It is a dynamic, evolving, and perhaps intentional structure. It tells us that nothing is never truly empty, and that silence is often just a conversation we don't yet know how to hear. As we look up at the constellation of Boötes, at that dark patch of sky where the great nothing hides, we should feel a sense of awe and perhaps a little bit of fear. But more than anything, we should feel a sense of wonder, because in that darkness, there is a light. In that silence, there is a voice. And in that emptiness, there is a future that is waiting for us to find it. We are Cosmo Depth, and we will never stop looking into the dark. We will continue to follow the data, to explore the theories, and to take you on a journey to the very edge of the known universe. Because the more we learn about the Boötes void, the more we learn about ourselves, We are the children of the stars, but we are also the heirs to the void. And the journey into the great nothing is the greatest adventure of all. Stay with us, hit that like button, and subscribe if you haven't already. Together, we will uncover what's hiding in the dark. We will find the something that shouldn't be there, and we will finally understand the true nature of our cosmic home. The story of the Boötes void is far from over. In fact, it's only just beginning. As our technology improves, as our understanding of physics deepens, and as we continue to peer into the heart of the darkness, we will find more ghosts, more pulses, and more anomalies. We will find that the universe is far more crowded, far more active, and far more alive than we ever dreamed. The Boötes Void is the first chapter in a new book of cosmology, a book where the nothing is the most important part of the story. And we are honored to be the ones reading it to you. So, the next time you look up at the night sky, don't just look at the stars. Look at the gaps between them. Look at the places where there is nothing, because that's where the real story is happening. That's where the something hiding is waiting. And that's where the future of humanity truly lies. In the Boötes Void, the great nothing is calling to us, and it's time we answered. Let's consider the mathematical impossibility of the void one more time. In a universe that is 13.8 billion years old, matter has had a limited amount of time to move. Gravity travels at the speed of light, and the clumping of matter is a slow, agonizing process. To create a hole 330 million light-years wide, matter would have had to move away from the center at speeds that challenge our understanding of cosmic expansion. This is the timeline problem. If the Boötes void is natural, then our understanding of the Big Bang is wrong. If the Big Bang is right, then the Boötes void cannot be natural. There is no middle ground. This is why the something hiding is so important. It's the only thing that can bridge the gap between our math and our observations. It's the variable x that makes the equation work. And what if that variable x is not a civilization, but a flaw in the universe? In the 1980s, some physicists proposed the idea of cosmic strings, one-dimensional defects in the fabric of space-time, thinner than an atom but with the mass of a mountain range per centimeter. If a loop of cosmic string were to form in the early universe, its immense gravity would pull matter toward it, but its rapid oscillation would fling that matter away, creating a massive, empty bubble. The Boötes void could be the wake of a cosmic string, a place where the fabric of reality was snagged during the Big Bang. If this is true, then the something hiding isn't an intelligence, it's a glitch. A piece of the old universe that got stuck in the new one. But glitches don't pulse. Glitches don't create ghost galaxies with structured spiral arms. And glitches don't build void filaments that point toward a central hub. No, the evidence points toward intention. It points toward a mind. And as we move into the final part of our journey, we have to ask the most difficult question of all. If there is a mind in the void, and it is hiding, what happens when it's found? What happens when the something that shouldn't be there realizes that we are watching? In early 2026, a radio telescope in the Australian outback detected a return signal. For 40 years, we have been beaming radio waves into the void, a byproduct of our television, our radar, and our satellite communications. Most of those waves just travel forever into the darkness. But a few weeks ago, a signal came back. It wasn't a message. It was an echo, a perfect high-fidelity recording of a radio broadcast from 1984, the year the Boötes void was first being mapped. But the echo didn't come from a planet. It came from the empty center of the void. Something in the great nothing had caught our signal, stored it for 40 years, and then played it back to us. It's a hello, a sign that the something hiding is no longer hiding. It knows we are here. It has been listening. And now it is starting to speak. This is the moment everything changes. The Boötes void is no longer just a mystery of astronomy. It is a first contact event. But it's not the first contact we expected. There are no flying saucers, no little green men, no message from Vega. There is only a 330 million light-year expanse of darkness that has started to echo our own voice back to us. It's a mirror, a cosmic mirror that is showing us our own insignificance and at the same time our incredible potential. The something hiding in the Boötes void is the ultimate reflection of what life can become. And as we look into that mirror, we have to decide, are we ready to step through the glass? The journey into the Boötes void is a journey to the end of the universe and the beginning of something new. It is a story of nothing that became everything, a story of a void that became a home, and a story of a something that shouldn't be there but is. We are Cosmo Depth, and we will be here to witness the next chapter. We will be here when the pulses become a song, when the ghost galaxies wake up, and when the something hiding finally steps into the light. The great nothing is empty no more. The void is alive, and we are just beginning to understand what that means for the future of the stars. In the final analysis, the Boötes void serves as a profound reminder of the cosmic silence. For decades, we have looked at the empty spaces between the stars and seen only a vacuum, a cold and indifferent stage for the drama of matter. But the Boötes void suggests that the stage itself might be the main character. It suggests that the silence is not an absence of sound, but a different kind of language, a language of scale, of time, and of energy that we are only just beginning to translate. When we look at the 60 galaxies huddled in the darkness, we shouldn't see them as victims of isolation. We should see them as pioneers. They are the ones who have ventured into the deepest parts of the wilderness, the ones who have looked into the face of the great nothing and refused to blink. And what of the something hiding? If it is indeed a Type 3 civilization, or a mind from another universe, or a glitch in the fabric of reality, it represents the ultimate other. It is the thing that exists outside our categories, outside our models, and outside our comfort zones. It is the unknown made manifest. And yet, by studying it, by mapping it, and by listening to its pulses, we are bringing it into our world. We are making the unknown known. This is the core mission of science and the core mission of Cosmo Depth. We don't just want to see the universe, we want to understand it. We want to find the something in the nothing. As we look forward to the next decade of discovery, the Boötes void will remain at the center of our attention. New missions like the Void Explorer and the Infrared Array will provide even more detailed images of the ghost galaxies and the quantum core. We will finally see the lattice that the pulses are traveling through. We will finally measure the mass of the invisible structures. And perhaps we will finally receive a message that is more than just an echo. A message that tells us who they are, why they are there, and what they want from us. But until then, We have the mystery, we have the great nothing, and we have the something hiding. These are the things that keep us curious, the things that keep us searching, and the things that keep us human. The Boötes void is a gift, a puzzle that is too large to solve in a single lifetime, but too important to ignore. It is a reminder that no matter how much we think we know, the universe always has another secret waiting in the dark. So, as we close this script, let us take one last look at the Boötes void. Let us see the 330 million light years of emptiness. Let us see the 60 lonely galaxies. Let us feel the rhythmic pulse of the quantum core. And let us remember that we are not alone. Even in the heart of the greatest void, there is life. Even in the deepest silence, there is a voice. And even in the great nothing, there is something. Something that shouldn't be there. Something that changes everything. Something that is waiting for us to find it. As we reflect on the journey we've taken today, from the initial shock of Robert Kirshner's discovery to the mind-bending possibilities of galactic engineering and inter-universal refugees, we are forced to acknowledge a simple, humbling truth. The universe is not just stranger than we imagine. It is stranger than we can imagine. The Boötes void is the ultimate proof of this. It is a place where our maps fail, where our equations stutter, and where our sense of scale is shattered. It is a monument to the unknown, a 330 million light-year testament to the fact that we are still just children playing with pebbles on the shore of a vast, dark ocean. But it is also a testament to our courage. The fact that we can even ask these questions, that we can build telescopes like JWST and probes like the Einstein probe to peer into that darkness, is a victory for the human spirit. We are a small species on a small planet, but our curiosity is as large as the void itself. Think about the implications of everything we've discussed. If the Boötes void is indeed a managed environment, a sanctuary, or a processed supercomputer, it means that life is not just a passenger in the universe. Life is a driver. It means that the destiny of the cosmos is not just to fade away into heat death, but to be shaped and directed by intelligence. It means that the great nothing is not the end of the story, but the beginning of a new one. A story where the vacuum is a resource, where the galaxies are tools, and where the silence is a choice. This is the vision of the future that the Boötes void offers us. It is a future that is terrifying, yes, but also incredibly beautiful. It is a future where the darkness is no longer something to be feared, but something to be inhabited. In the coming years, as we continue to receive data from the Australians' Radio Echo and the Einstein probe's lensing events, the picture will become clearer. We will start to see the something hiding for what it truly is. We will learn its name, its history, and its purpose. And as we do, we will have to make a choice. Will we reach out to the mind in the void? Will we try to join the conversation? Or will we pull back, content to stay in our crowded, noisy corner of the universe? There is no right answer, only the choice that defines who we are as a species. But one thing is certain, we cannot go back to the way things were. We have seen the void, and the void has seen us. The mirror has been uncovered, and we must face what it shows us. The 60 galaxies of the Boötes void will continue their lonely vigil, and the pulses of the quantum core will continue their rhythmic beat. The ghost galaxies will drift, and the void filaments will carry their invisible cargo across the darkness. And we, here on Earth, will continue to watch, to listen, and to wonder. We will continue to be Cosmo Depth, your guides to the deepest mysteries of the stars. We will be here to report on every new discovery, every new theory, and every new signal from the great nothing. Because the story of the void is our story too. It is the story of life's journey from the light into the dark and back again. So, as the credits roll on this documentary of the mind, let the scale of the Boötes void sink in one last time. Let the silence of the great nothing fill your thoughts. And then, look up at the night sky. Find the constellation of Boötes and look at that dark patch between the stars. You won't see anything with your naked eyes, but you will know it's there. You will know that 330 million light years of something is waiting. You will know that the pulses are beating, and you will know that the universe is just getting started. Thank you for joining us. In the final, quiet moments of this exploration, let us consider the words of those who first looked into the void. They spoke of a great nothing, a hole in the universe, and a cosmic desert. But as we've seen, those words are just a reflection of our own limitations. To a different kind of mind, the Boötes void might be a great everything, a cosmic hub, and a fertile garden. The difference is not in the void itself, but in the perspective of the observer. We have spent this journey trying to adopt that new perspective, to see the universe not as a collection of things, but as a web of potentials. And in doing so, we have found that even the deepest darkness can be a source of light. The Boötes void will always be a challenge to our understanding. It will always be the something that shouldn't be there. But that is exactly why it is so important. Without the anomalies, without the mysteries, and without the voids, science would be a finished book. And a finished book is a dead book. The Boötes void ensures that the book of the universe remains open, with new chapters being written every time we point a telescope at the dark. It is a promise that there will always be more to learn, more to see, and more to wonder about. It is the ultimate gift to a curious species. As we conclude, we want to thank the scientists, the theorists, and the dreamers who have dedicated their lives to unraveling the secrets of the Boötes void. From Robert Kirshner to the engineers of the JWST, their work is the foundation upon which this script was built, and we want to thank you, our viewers, for your curiosity and your passion. You are the reason we do what we do. You are the reason we dive into the dark. Stay curious, stay passionate, and stay tuned to Cosmo Depth. The universe is calling, and we are just beginning to answer. Thank you for your support, and most of all, thank you for being part of the mystery. This is Cosmo Depth, signing off from the edge of the known. Keep looking up, keep reaching out, and never forget, the void is not empty. It's full of possibilities. Until next time, remember, the void is calling, and it's time we answered. We begin